Chapter 6 Review. Let's review the Laplace transform. First, we have a definition. If you're given a function of time, then the Laplace transform of that is defined as the integral from 0 to infinity of e to negative st times ft, and the result will be a function of s instead of a function of t. And we'll have quite a few formulas. Out of 1 equals 1 over s, out of e to the at equals 1 over s minus a, out of t to the n equals n factorial over s to the n plus 1, and a pair of sine and cosine. Sine at would give you a over s squared plus a squared, and a cosine would give you s plus s squared plus a squared. And the combination of these functions can be given from the two formulas. If you multiply a function f by e to the at, then the result, the transform would just be the same f with a shifted s. If you have a t times f, then it will be the negative derivative of that capital F. And with this formula, we can combine these things together. For example, let's see what will you get if you have e to the at times t. Well, then t would give you 1 over s squared, right? Then s should be replaced by s minus a, right? And let's see what you have if you have t times sine at. Then you will have negative sine at will give you a over s squared plus a squared prime, right? And that would give you s squared plus a squared squared, and numerator is a times, it should be negative 2s, but negative sign cancel, so just negative s. Right, so that's your t times trig function. Alright, now let's see if we can use them to figure out the inverse transform. What if you have given a s minus, say, 2 cubed? Well, then we know the negative 2 means there is a 2t there, right? Then you can do the inverse transform of 1 over s cubed. And we know that is just a t squared over 2, because t squared would give you 2 over s cubed. Right? Now let's look at the harder problem. What if you have s squared plus 1 squared? Well, if you don't have a square, then we know the answer is sine t. But if a square, well, we don't have that in our list, but we have something similar. Do you look at this guy? You have s squared plus a squared then squared, just like this, right? Except the numerator has s here, but it has no s there. So maybe sine does not give you what you want. Let's look at a cosine. So let's see, what do you have if you do a cosine t? Then, of course, you know it's s over s squared plus 1, right? What if you do t cosine t? Then you can take its derivative and negative sign, right? So what do we get? S squared plus 1 squared, and the numerator would be s prime is just 1, and times that minus s times 2s, right? And you have a negative sign. So the numerator would s squared cancel that one of them. You get 1 minus s squared. So the negative sign would give you that, right? Okay, so that's t cosine. you have s squared minus 1 in the numerator. But what we want is 1, right? Well, you may say there's no way to get the s off because, sine wouldn't have the s. Sine is just s, not s squared, right? But look at this. What is sine t? Sine t is just 1 over s squared, right? Well, but if you can write down it in this form, do you see what's going on? This term and that term, if we take their difference, then we get 2. You get it? So if we do sine t minus t cosine t, then we get the difference. Sorry, s squared plus 1 squared. You see that? So, what's our answer? Just divide by 2. Right? So you can see we can use these formulas to find out the inverse transform of 1 over s squared plus squared. Okay, that's it for the Laplace transform itself. Now let's see if we want to use it to solve a differential equation involving y double prime. Then we need to know what is that, right? Remember the formula? It's well, let's start from y single prime. How about that? Then you will have negative y0 plus sy, right? And how about double prime? Then just replace y by y prime in the last formula. And again, you will have s times y of 0 plus s squared capital Y, etc. Right? So that's it when you do the derivative. And one more thing we need to know is, what if you have a step function? If you have a step function, then times a function. And how do you do the Laplace transform? Well, this part will give you e to negative sc. And then, if you just do the Laplace transform of that f, you have a problem, because this is f, and this is c. So when you do uc times f, you are eliminating this part is gone, right? You only have this part left. So your function will become like that, right? So if you put f here, which will use this part, which is not there anymore, so you have to shift the function backward. So you'll get something like just this. Okay, so you have to do shift to the left, which means you have t plus c here. So that's your formula. On the other hand, if you are doing inverse transform, no, not capital, then you will recover the step function, but you have to move your function to the right to undo what we did over there. All right, so this is a pair of formula that you use to find out the function involving step function, the solution involving step function. And one more thing is delta function, and that's easy. If you have delta function at c, then the transform is just a negative e to the negative sc. And another property of delta function is that if we multiply by a function, then it's equivalent to multiply by the function's value at that point. Alright, that's it for the Laplace transform itself. Now let's see an example. Let's see two examples. The first one, we will have a function without step function. And then we will see an example with step function. Alright, so that's your function with initial condition. If we do it in the traditional way, then you will see your y1, y2 would be, you can solve it, it's pretty easy, it's these two, right? So you have c1 and c2 like that, then your particular solution for your right hand side, you will have t, so you give at plus b e to the t, right? But that is not correct because e to the t appears here. So you have to multiply the whole thing by t, right? So you need to figure out what is a, what is b, and then you determine c1, c2 from your initial condition. So your final solution would look in that form, but with all these numbers to be determined. Now let's see what do we get if we do Laplace transform. And since we have no derivative in the beginning, so our solution, our transform is just a negative no prime, so it's just a negative s and plus s square y and minus y, right, equals, okay, what is that? T would give you 1 over s, but the e to the t will give you the 1 over s square, then e to the t will give you the shift, so that's what you have, right? S minus 1 squared. So what is the s? What is the y? You have s plus 1 over s minus 1 squared divided by s squared minus 1. Right? So let me simplify that. So that means you have s squared minus 1, s minus 1 squared. Then the numerator is s minus 1 squared plus 1. Okay? So that means your numerator is a third order polynomial, and denominator is fourth order. And the denominator can be written in this way. Right? S minus 1 times s plus 1. Then times s minus 1 squared. So the numerator, if I expand it, it will be 2s cubed minus 2s, sorry, there's no 2. S cubed minus 2s squared plus s plus 1. Right? You have s cubed minus 2s squared plus 2s plus 1. And that can be written as s minus 1 cubed and then plus s plus 1. And we call this as squared plus bs plus c, and this is called d. So let's try to figure out what is a, b, c, d. Okay. So you have as squared plus bs plus c times s plus 1 plus d s minus 1 cubed equals s cubed minus 2s squared plus s plus 1. Alright, so let's expand to the left hand side. You have as cubed plus bs squared plus cs, then times 1, you get as squared plus bs times c. Then the d part will give you 4 terms, plus ds cubed minus 3ds squared plus 3ds and minus d. And the right hand side equals s cubed minus 2s squared plus s plus 1. So you're matching the corresponding coefficient. A plus d equals 1, b plus a minus 3d equals negative 2, and c plus b plus 3d equals 1, and c minus d equals 1. Okay, you have 4 equations with 4 unknowns. And let's see how do we solve that. So the first one, let's in terms of d. Okay, you can see a equals 1 minus d, and c equals 1 plus d, and they plug into this equation. B plus 1 minus 4d equals negative 2. So we move the 4d over there, and this negative 1 and 1 move there, the negative 3. So b equals 4d minus 3. Let's plug into the last one here. 1 plus d plus 4d minus 3 plus 3d equals 1. Cancel the 1 and move the 3 there. So you have 8d equals 3. So d equals 3/8. Right, then let's see what is a. A equals 1 minus d, so it's 5/8. And what is c? C equals 1 plus d, so it's 11/8. It's kind of big. And the last one is b. B equals 4d minus 3. So b equals 4d, which is 2/3 minus 3, that's negative 2/3, negative 3/2. Right? So that's what we have. So let's put them together. So our solution would be, do you remember what do we have? So you have, okay, A, B, C, and then D. Okay. Your y is s minus 1 cube, ABC. A is 5/8 square, and B is 3/2 s plus 11/8. Then you have plus 3/8 s plus 1. Okay, how about we factor out 1/8 to make it easier? So you have 5s squared minus 12s plus 11 s minus 1 cube plus 3 s plus 1. Okay, that is not done yet because we want to write down this as a s minus 1 cube. Then write down this as 5 s minus 1 square plus something s minus 1 plus something, so that you will have the cancellation of s minus 1 in the end. Okay, so you have 5s squared minus 10s, so you need a negative 2s to get to the negative 12s. Then you have 5 plus 2 equals 7, then you plus another 4 to get 11. Alright, now we're done. So we have 5/8 1 of s squared minus 1 minus 1/4 1/4 s minus 1 squared, then plus 1/2 s minus 1 cube. Then last term is 3/8 s plus 1. Okay, finally we can write down what's little y. Little y is 5/8, and this term will give you e to the t. Then you get negative 1/4, and this will give you t with a shift. Right? The next term is you have 1/2, but this will give you t squared over 2 with a shift. Right? Then the last term is 3/8 with the negative shift. Okay, so the only difference we can improve is to merge this 2, to get a 1/4 there. Okay, so that's your result. And you can see, indeed, you have the terms we stated in the beginning. You have this e to the t, e to negative t, and t squared et, and t et. Alright, so that's our result. Now let's do one more problem to finalize the review. This time we will have a delta function and a step function. say you have a delta function in your solution, in your equation, and this g of t is defined piecewise. It's t when t is less than 1 and stays at 1 when t is greater than 1. So if you plot it, it will be linear growth, then stay there. Okay, and the initial condition is chosen to be simple, so that everything is 0. Alright, now let's find out this Laplace transform. So because the initial condition is 0, so you just have s squared minus 1 times capital Y. And to write down the transform of g, you need to write down what is g in the step function. You have t plus u1 and times the change, right? Okay, so, and then let's do it. So you have L of t plus u1 times 1 minus t plus delta t minus 2. Alright, so for t, it's 1 over s squared. And for u1, okay, what do you do for u1? You have e to the negative s, right? Then when you do the transform of 1 minus t, remember you have to shift to the left, which means you have to replace t by t plus 1. Okay, and then what is that? This is just negative t. So what is L of negative t? It's negative 1 over s squared. Alright, then the last term is e, it's just a negative 2s, e to negative 2s. So we can write down what is our y. It's s squared minus 1, then you have 1 over s squared, and then negative 1 over s squared e to the negative s, and plus e to the negative 2s. Okay, so let me write down into partial fractions. The first term is s squared minus 1 minus s squared minus 1. Because if you put them together, you will see the numerator becomes s squared minus s squared minus 1, which is 1, right? But that's not done yet because we have to split the first term into s minus 1 and s plus 1. And you can see if you add them together, you get 2s. But if you do the subtraction, you will get 2, right? So we divide by 2, you get 1. Alright, so that's the first term, completely into partial fraction. So I just use this. You will use this form. And then the second thing is exactly the same. Okay, and the last term is, let me just write down here. Last term is, okay, I don't write down, that's confusing. So I write down here, plus, let's split this only, which is something we just did, right? S minus 1 minus 1 half s plus 1 and times e to negative 2s. Okay, so we're ready to write down our solution. 1 half e to the t minus 1 half e to negative t minus t. Okay, that's our part 1. And part 2, this will give you the step function at 1. Then, when you write down this thing inside, remember you have to write down the thing here, but replace t by t minus 1. It's t minus 1 minus negative minus 1 half e to the 1 minus t, and then you have to minus t minus 1, so like that. Okay, and the last term is another step function at 2. And you do the inverse transform, which is 1 half e to the t minus 1 half e to the negative t, but you have to replace all the t by t minus 2, and this t minus 2 will be that. Okay, so that's your final answer. Okay, just be careful every step you're doing it following the correct formula. Alright, that's it for the review. And we will review chapter 2, 3, 5, and then have the exam. Okay, that's it.